Hi there. Welcome to the Daily Space Weather. I would be your host, Dan, aka smAsho. Today we'll be talking about the coronal mass ejection that we forecast yesterday. So please subscribe, share with your friends, foes, science noobs, and science pros, and leave us a comment. First thing we're going to do is some stargazing here at the Smash News Network by looking at the closest star, otherwise known as Sol, or perhaps the Sun. This is actually a composite from the SDO browse data, the Solar Dynamics Observatory, looking at three different wavelengths, 335, 193, and 94 angstroms. And let's take a look at the coronal mass ejection that's just occurred in the past 24 hours from the viewpoint of Lagrange point 1, where the SOHO LASCO is located. So here is the view from the LASCO C3. Allow me to get off screen. And you can see that coronal mass ejection coming out of the northwestern limb. And also a planet with rings. It's Saturn. So here's a more close-up view of that same data, basically. It's the LASCO C2. Show you a little bit more resolution of that. You can see that coronal mass ejection ejecting. And here's the view from, we'll go to Lagrange point 5, where stereo A is located, as it trails the Earth, orbitally speaking. So here's the raw data. And while we're not able to tell you how we forecast coronal mass ejections, once again, the proof is in yesterday's videos. If you'd like the most advanced notice you could possibly get, perhaps subscribe to our channel. Press the notification bell. Maybe become a patron, as patrons found out even before YouTube did. And here's the difference image. This is simply the pixels subtracted from the previous pixels, and you can also often see additional detail by looking at the difference image. You can find all of this data yourself at the Integrated Space Weather Analysis page, or ISWA, and we look at it on the regs. And let's look at some more data here. Here is, once again, the local yellow dwarf. This is colorized magnetogram as well as the 171 angstroms wavelength. And sunspot 2801 is setting. I'm not sure if it's lost its name yet, but it will be out of view soon. We'll go back to zero sunspots shortly. Quite low levels of solar activity. Here's what's going on in the solar system. This is where planets and so forth are located. And there's where we'll be in 1 week. It'll be a new moon as Mercury swings in between Earth and the Sun. And here's a star chart if you're wondering what's going on above your head. Perhaps use in-the-sky.org. It's what I use. I like to draw in the ecliptic and face mine to the south, as I'm currently facing south, and my sofa faces the south as well. Also from the northern hemisphere, the ecliptic is to the south, which is what that yellow line is. And the 10.7 centimeter radio flux is at 74. So pretty low levels of radio flux here, not quite solar minimum levels, but quite low. Here's the historic chart for the 10.7 centimeter radio flux, and that is a radio output from the outer solar corona. So there's the context of 1 year. And welcome to Cycle 25. Welcome to the Neo Renaissance. Welcome to our channel. Thanks for tuning in, new viewers, as well as loyal regulars. So there's a sunspot number. This has recently been updated on the Space Weather Enthusiast dashboard. You can see the sunspot number from cycle 24 as well as through cycle 25, and you can see how proportional that is to the 10.7 centimeter radial flux. Practically the same graph. Every major spike is represented on both graphs. So that's the radial flux going back about 11 years. Next, we've got some HelioViewer movies. First, I'm going to show you the fields real quick before we show you high-res images at the end. No areas of major magnetic organization on the solar disk. There's 304 angstroms, and there's the fade back to 171. And before we show you HelioViewer movies, I just want to check the life of the stream, and everything looks just fine here at the Smash News Network. So here's 193 angstroms. A couple of coronal holes there south of the equator, just in the Earth-facing zone. And we've just seen a coronal hole wind stream subside, which got the Earth into geomagnetic unrest conditions, produced some great auroras and so on. Here are a couple more wavelengths of the full solar disk. Here's 171 angstroms. And for some reason, the text for Earth scale is on the sun, and the Earth scale is over here. I don't know what happened. I think it's because they have graphics for the image and HTML for the words Earth scale. Here it is in 304 angstroms, ionized helium. The last two, 193 and 171 angstroms, are both ionized iron emission spectra. And we'll show you some close-ups of where the major activity is going on. The main activity is going on, at least, maybe not so major. It's happening in the northwest corner. We'll save those for the end of the video. Next, we'll take a look at volcanoes. And we've got another entry to the list here, an update on one of the areas of volcanism on the planet. So Raung on East Java is now producing a 12,000-foot ash plume. I think that's an uptick on Raung. Correct me if I'm wrong. Dukono is exploding. Flight level 060. It's a 6,000-foot ash plume. Volcanic ash dissipated and steam and gases only from Popocatépetl down near Mexico City. Fuego in Guatemala, volcanic ash not seen in satellite. Please don't attempt to pole vault the caldera. It could be erupting. There could be clouds obscuring the satellite imagery. Sangay in Ecuador is exploding. Flight level 230. It's a 23,000-foot ash plume. I think that's an uptick at Sangay. Revenador exploding. Flight level 150. 15,000-foot ash plume there. Sabancaya exploding. Flight level 260. It's a 26,000-foot ash plume. And Soufrière on Saint Vincent in the West Indies is doing an effusive eruption, and it seems to be exhausting its water supply. So now we see primarily sulfur dioxide, hydrogen chloride, hydrogen fluoride, and hydrogen sulfide emissions. Why is there so much hydrogen coming out deep out of the planet, folks? Why is there so much hydrogen? Did you watch yesterday's video? Are you familiar with the hydrogen phasing? Do you know what happens to hydrogen at extremely high pressures? We'll make a video about it at a later time, perhaps a cosmology segment. Anyway, Soufrière seems to be exhausting its water supply, mainly producing other volcanic gases now. And let's move on to earthquakes. The largest of the past 24 occurred near Taiwan. It was a 5.4 magnitude at depth. Out there in the ocean, there's the location of that 5.4 magnitude quake. The depth was 126 kilometers, and that happened a few hours before we made the video. Let's go up the list. There's a deep quake in Mexico, extreme southern Mexico. .1 in Tonga. I would note this one in West Africa, that 5.0 in Guinea. That's pretty far away from the plate boundary there on the African plate. And let's just continue up the list here. A couple quakes in central U.S. Here's a deep quake at Bolivia, and we see lots and lots of deep quakes in western South America. There's another deep quake in western South America at Peru. It's a 4.1 at 188 kilometers depth. And let's continue on. By the way, I would invite all of our viewers to check out smAshomash.com/forum. And we had a viewer who was talking about posting dreams. So we've got a cosmology forum, Earth and Geophysics, a free-for-all forum, General Science. And in the free-for-all forum, there are more forums as well, but in the free-for-all forum, we have a pinned post for the dream log. Everybody should keep a dream log, and if you'd like to share yours with members at smAshomash.com, go ahead and post your dream. It's all free. smAshomash.com/forum. If you want to read about our mission, head to smAshomash.com/forum/mission. And you can link to all that from our homepage as well as to our social media, smAshomash.org, smAshomash.com. You can also find our merch there. There's the link to the forum. There's our Teespring stores. And today's featured product is available at smAsho Merch. And if you click on that, you will find our Redbubble shop. And one of the products available there is the Google Bias shirt. So today's featured product is this shirt, which incredibly was actually featured on Zero Hedge's homepage. So to use it in a sentence, I Googled it, and now I know less about it. I used the Google Junkware search engine to obtain biased search results. You can find a whole bunch of products there, various different types of shirts, sweatshirts, magnets, art prints, mugs, tumblers, even skins for your iPad or your iPhone or your Samsung Galaxy. And again, you can link to all of that. I'll leave the other designs up to you to find out. So check it out. Here's our Instagram page. And look at this. There's the shirt that I'm wearing on the Zero Hedge homepage. I took screenshots of it. How about that? Something I was not expecting to see today. And perhaps you'd like to follow us on Instagram, instagram.com/smAshomash. Now today's Smash stream is actually being streamed live to Twitch. Thanks to our new viewers over at Twitch. We gained a few followers there. Cheers. Thanks for tuning in at twitch.tv/smAshomash. The mobile app is great. Most importantly, please press like and subscribe on YouTube. We have the most content there. We create the most exclusive content there. And yesterday, indeed, we created another exclusive video, the Daily Space Weather Supplemental, where we forecasted the coronal mass ejection.
I decided to do a Daily Space Weather Supplemental.
And I imagine the reason that nobody else forecasts coronal mass ejections is because they can't. But there's yesterday's video. We made it in the afternoon as the coronal mass ejection we forecasted did indeed occur. Thanks to our new subscribers over at BitChute. And I would recommend all of our viewers branch into Alt Tech. Wherever you're viewing this video, there is exclusive content on the rest of our sites. So please check us out on all of our social media sites. And again, you can find all of those at smAshomash.com. Thanks everybody who gets involved. Let's do a cosmology segment. It'll be brief. First, we'll thank our patrons. Hey, patrons. Thanks for being the true source of funding for the content, as our pathetically low views and stagnating subscriptions earn us just about nothing on YouTube. We earn just this side of $0 per month on YouTube. So thanks again to our patrons. Patreon.com/smAshomash. If you want the earliest and fastest updates about things like solar activity, Become a patron, patreon.com/smAshomash. Let's pick a random quantum number between 1 and 1031. Today's number is 186. So we'll head to the Neil Gorell Swift Bat X-ray Observatory, and we'll scroll down to 186, which is Large Magellanic Cloud X3, which is a BH. Maybe I should know what that is. But I don't. What a BH is escapes me. But anyway, there are the X-ray outputs from Large Magellanic Cloud X3. Oh, right. It stands for black hole, which I prefer to refer to as a massive radio source. So let's see if we can image this on SIMBAD. Here's the data on SIMBAD. We'll see if we see anything there. And it's not going to show up there, so we'll head to Aladdin Light and look at it in some different wavelengths. So first we'll see if it shows up in infrared light on the 2 mass. And there it isn't. Let's see if it shows up on the Chandra, as it is an X-ray source. How about the multi-mirror XMM Newton project? And there's a great view of that massive radio source. Large Magellanic Cloud X3, believed to be a black hole. I'll refer to it as a massive radio source. That's today's cosmology segment. So let's move on to get through a whole bunch more data, as it's the daily space weather. Next, we'll look at the GOES X-ray flux here at the Smash News Network. And we don't see any solar flares of note. Nothing even in the B-class range. So let's move on to look at the proton flux. And since no coronal mass ejections are striking the Earth, well, we don't see any spikes in the proton flux. By the way, the coronal mass ejection that we've been talking about in the titles and in the supplemental videos looks like it will most likely miss the Earth to the northwest, once again, as I forecasted. Next, we'll look at the real-time solar wind. And we're still seeing a bit of an elevated solar wind velocity here. Solar wind velocity at around 500 kilometers per second. Solar wind density 5.77 protons per cubic centimeter. And check it out, the geospace magnetosphere movies have changed. Well, first the KP index, a measurement of global geomagnetism, at 3, so slightly elevated. We got into a brief period of geomagnetic unrest. Late in the day yesterday at about 2000 hours universal time. So here's the geospace magnetosphere movie. This is 4 hours of data. You're looking at magnetohydrodynamic pressure measured in nanopascals. And that relatively high pressure there is caused by that high-speed solar wind. So that coronal hole wind stream lasting quite a long time. Again, nearly 500 kilometers per second, creating some pressure. And here are the magnetic perturbations. You're looking at geospace delta B, changes in the Earth's B field. And they've totally changed this graphic around now. I'm not sure if I like it better or less, but it looks like it's higher resolution, so I guess I have to like it better. I would also note that we've been seeing regular high amounts of change in the B field down here south of South America, near the Antarctic continent. Perhaps we have 2 south poles as well as 2 north poles. Look at the amount of spread between this area of high delta B and that area of high delta B. Could we have 2 south poles already? Are there enough magnetometers down there? I frankly have no idea. But we certainly have 2 north poles, and you can see that the size of these overall perturbation spirals is pretty similar. So welcome to the geomagnetic excursion. Welcome to the neo-renaissance. It's all part of the reason why we make the channel. And we started the channel at the moment of solar minimum, just before the true solar minimum. between cycle 24 and 25 intentionally to study the sun when it's at a very low state, at least through half of a solar cycle. So here's the GOES magnetometer, and you can see very spiky readings here. What can I say? The Earth is about to move into an opposite polarity current sheet. So currently we're in the North Pole current sheet, and by tomorrow we will be back in the South Pole current sheet, shown here in red. This larger current sheet over here out towards stereo A. This is stereo A, that's Lagrange 0.5, and this is stereo B, that's Lagrange 0.4. This data is derived from 51 ground-based magnetometers. It's all part of the National Sunspot Observatory. And we view this daily as it's one of the most important pieces of solar data, the magnetism. Keep in mind the data is 2 hours old and can change suddenly. Here's a line of sight field plot, which shows you the sun's B field. Now we were looking at the Earth's B field in those geospace magnetosphere movies, the ground magnetic perturbations. This is the sun's B field, which is also the interplanetary magnetic field. And really the B field is a net of these two fields. So there's the North Pole. Here's the North Pole poloidal field. Here's the South Pole poloidal field. And to the extent that these fields overlap, that's the B field. And the B field is what we're measuring when we look at the real-time solar wind, the BTBZ. That is the B field. The BZ is the extent. If the BZ is negative, you're looking at South Pole dominance on the B field. And if the BZ is positive, you're looking at North Pole dominance over the B field. And last but not least, we'll take a look at the coronal hole line of sight field plot. Nothing to write home about there. And here's the coronal magnetic field plot, the field plot of the sun's atmosphere. And by the way, stars are not only not electric inside, they're not made of a gaseous plasma. Here's a fairly self-explanatory diagram, and before I continue on, I just want to check the life of the stream again. And once again, thanks to everybody that views the videos, whether you're viewing it on Twitch, on BitChute, or on YouTube. Especially thanks for viewing the live premieres. We greatly enjoy viewing the live premieres with our viewers, as I'm not only smAsho, I'm also a client. And thanks to Granddad for viewing the videos. Cheers. So here's just a diagram of atmospheric layers. Keep in mind the altitudes here are in kilometers. Here's another diagram. Keep in mind the altitudes here are in miles. Next, we're looking at some electron features. We're seeing some minor charging hazards over Mexico and Central America once again, as you can see there below my pointer. Electron flux at pretty low levels. There's a 3-day chart of the GOES electron flux measured by the GOES 16 at the F ionosphere layer. Here's a 1-year chart of the electron flux, and we're expecting a big increase after this coronal hole wind stream subsides. We'll show you the forecast in a minute. Here is the visualization. And you see quite high levels of electron flux there over South America, as well as some anomalies over North America and Antarctica. And there's the forecast. We're expecting a significant uptick in electron flux here, sort of at the end of that coronal hole wind stream. I won't get into the physics of it. It's a little complex, and this is the daily space weather video. So here is the ionosphere map. Now we're looking at just one layer. And this is basically around the altitude of about 300 kilometers, approximately where the GOES 16 makes its measurements. It's the F of F ionosphere layer. Anyway, here's the latest image. It's looking pretty normal there. Nothing to write home about with the ionosphere. That image coming in at 9:30 Universal Time. Next, we'll do a little bit of meteorology stuff. Here are the jet streams of the eastern world. And I would note extremely kinked jet streams and extreme low pressure there south of Australia, and a big bend in the jet stream to the east of Australia. Doubled up jet streams over the northern hemisphere, and quite incoherent ones over the western world. Here's the western world. And we're seeing, once again, like yesterday, pretty extreme meridional jet stream flow, a doubled up divergence of the jet stream over the Atlantic Ocean, and extreme jet stream bends here around South America. Really, the entire continent of South America is a giant anticyclone. And anticyclones, they rotate counterclockwise in the southern hemisphere. And let's give you a quick view of how different the surface winds are. So there are the surface winds, and you can see practically no wind at all over the South American continent. But in the upper level, you've got high pressure. And look at the surface winds over the Atlantic Ocean. They are all over the place. And once again, there is the jet stream. That's the 250 hectopascal winds from nullschool.net. Next, the U.S. Doppler radar map. We're going to show you a couple snow forecasts. Some heavy snow over southern Minnesota and eastern Nebraska. And some wintry mix there over Wisconsin, Minnesota, eastern Iowa, and moving into northwestern Illinois. So here's the snow forecast for the Northeast, courtesy Tropical Tidbits. This is the GFS forecast, and we're going to go through until Monday morning. So there's the forecast until there's 12 o'clock Universal Time Monday morning, which would be 7 a.m. Eastern Time. Expecting a couple more inches of snow here in the Lehigh Valley. And if you're wondering where we're located, SMASH staff and I are located right here, about there, in Lehigh Valley, Pennsylvania. So that's the GFS forecast according to Tropical Tidbits. GFS not expecting another blizzard. And next we'll look at the same basic area here on windy.com. And it's fairly consistent there, expecting another inch or so according to the Euro forecast. That's the Euro forecast. And windy.com doesn't provide a snow depth forecast on the GFS model. And without looking deep into it, we'll move on to look at the cloud layer. And we use the shortwave radiation map as water vapor emits radiation. Ask a radio astronomer if you don't believe me. Look at the low clouds over the Atlantic Ocean once again. They're not contrails, they're not chemtrails, they're low clouds. They could be caused by cosmic rays. Check out the low clouds off of Texas as well. Some low clouds in the Gulf of Mexico. Here's the water vapor map. And there's the clouds again. And we use that shortwave radiation map to show us clouds when it's too dark to see them with the visible satellite, which is a little higher resolution. But this one is good too. We like to be able to see what's going on with the clouds at nighttime. And we have a funneling going on in here. We've got dry air spreading apart these areas of moisture. Two little atmospheric creeks. Yeah. Sending moisture up north and down south as dry air pushes in between, being funneled out of the southern Rockies. Maybe there's a lot of hot air coming out of the southern Rockies. I don't know. What YouTube channels do you watch? In any case, thanks to the SMASH team for not promoting fraud. Or do you promote fraud? Well, you can do whatever you want, but thanks SMASH team for viewing the content. Again, please visit our links, support the channel, become a patron, press like and subscribe, comment, share, etc. Especially on YouTube, as we need your help to get the content out there. And stay tuned for bonus features, as we've got to show you the high-resolution intensitygram and the high-resolution magnetogram to see if we still have sunspot 2801. So here's the intensitygram. And I think sunspot 2801 has either evaporated or gone out of view. It's actually broken down. It's degraded. It's no longer a sunspot. So back to 0 sunspots, folks. Here's the magnetic field situation from former sunspot 2801. And we'll close things out with the rest of our HelioViewer movies, the up-close views of the northwest corner. First, allow me to vanish. And there's 94 angstroms. It's exactly 1 day of solar activity. Shout out to Brett from Alaska. We hope your back is doing well. Mine is almost unshattered from all the shoveling that I did 2 days ago and on Monday. Here's 304 angstroms, ionized helium. We still do have significant filaments. There is still a possibility of additional coronal mass ejections. You can see some of the filaments up here, those dark areas, kind of draped across the north solar polar crown. Here's 131 angstroms, that same zone. And here's an extreme close-up in 171 angstroms, my favorite wavelength. Thanks again for tuning in, folks. Increase the probability that we will go full-time with these videos and do nothing but create content. It's about time to do so. Press like, subscribe, share. Tell your friends, foes, science noobs, and science pros about the channel. I don't see anybody else forecasting coronal mass ejections, probably just because they can't. Which is okay with us, and if you're wondering how we do it, sorry, it's a trade secret. Anyway, we're out. Remember, stare at the sun, don't drink, and if you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. May that solar wind be at your back.